넣으면 돼요.
아니 네가 이렇게 돼 있잖아. 근데 맵핑한 문제는 A, B, C, D, E, F, 1, 2, 3, 4까지만 맵핑해.
그럼 필요 없으니 이게 더 빨라요. 이제.
Where I have to invest on 2%. I only using 1 year. Oldest, I think 26.
He's an independent network security researcher from Secure Bits.
All right. Can you hear me all? Thank you very much for being here. I'm Eyar Samhouri. I work for CCIC and company in Greece. I'm also an independent security researcher. I've developed some security researches and projects. They are available on my website, www.securebits.org. I also have a security blog, which is www.securebits.org/blog. The title of this talk is Next Generation Reverse Shell. The agenda of this presentation, I'm going to start by giving introduction to reverse shell, introduction to modern security architecture, and the attacker challenges, and how we can look at the modern security architecture to develop next generation reverse shell that could stand in advanced penetration testing in modern networks. Then I'm going to speak about the theory of next generation reverse shell and the technical implementation of it, and the HTTP-based, FTP-based, POP3, SMTP-based, and NTP-based implementation of this technique. And then I'm going to introduce the Giant Reverse tool, which is the platform for next generation reverse shell. And I'm going to close by giving a little bit about the future enhancement of the tool and conclusion. Now, look at this. This appears as timestamp. In fact, it's NTP timestamp in hex code. It looks like this. However, the ASCII representation of this hex is ls-l, which is a shell command. So I'm going to also introduce something called shell over NTP, which is part of the next generation reverse shell. So let's start. What is reverse shell? Well, a normal shell or a normal remote shell, the client or the user connects to the server, accesses the server, and then gains a remote shell over that system. Now, there is something I want you to note here. When I mention the word the user, I mean the attacker, the hacker, the security professional, the pen tester, or just a normal hobbyist, or anyone else. So when I mention the user, I mean anyone who uses the reverse shell or next generation reverse shell. So a normal shell, the user connects to the server and issues the command to the server to be executed. However, in reverse shell, the client establishes the connection to the server, and the user is working on the server and issues the command back to the client to be executed. So the direction of the execution is on the opposite direction of session establishment. That's the difference between reverse shell and normal remote shell. Now, reverse shell is used to access systems behind firewalls. Now, when you establish a connection to a system in an internal networks that's behind a firewall, the firewall is going to block you if the firewall blocks all inbound connection. However, if the client connects to the outside, to the server, to you, and then you issue the command back to the server, you can have remote shell, which is in reverse established connection. So the purpose of reverse shell is to access compromised systems or normal systems that are behind firewalls. Now, that's the basic idea of reverse shell. There are some implementations, some tools that you can have a basic reverse shell. I'm going to cover these basic implementations. And then I'm going to address the limitations and weaknesses of these implementations, the current implementation of reverse shell, so we can understand the need of next generation reverse shell. Reverse shell, normal reverse shell can be established using Netcat, which is a famous network security tool. Netcat can work in a client and server modes. You can see in the slide, you can execute the following command on the server, which is the server controlled by the user, and then you run the second command on the client, which is the system behind the firewall. And then Netcat is going to establish connection back to the server, and at the same time, it will attach the shell process /bin/sh to the TCP stream, and you are going to have reverse shell to the client. Reverse shell can also be implemented using SSH. Using SSH, of course, is going to be completely encrypted. Now, on the client, which is the remote machine, you issue the first command, which actually tells the SSH server on the client machine to connect to the remote machine or the server IP, the remote server. And then once it connects to the remote server on SSH, it's going to listen on port 1234. And then the user who's actually gaining this reverse shell will go to the server and issue the second command, and he will connect to his PC, which is listening on port 1234, which was already established by the client. So you're going to have reverse shell over SSH. Here is a very small script, for example. Let's say the compromised system. You have compromised a system, and that system doesn't have SSH or Netcat. Here is a small script. It's a Perl script developed by Julius Blends, and it initiates a connection back to the server, takes the command from the server, executes it on the client machine. This has a problem, though, which is it does not preserve the current working directory, which means once you have this shell, it doesn't provide you with interactive shell. You cannot issue command like cd or change working directory and so on. Another tool developed by Van Houser from the Hacker Choice, it's called reverse www shell. It's actually a little bit better than the previous implementations, though it has its own weaknesses. It's a proof of concept of his paper he has written. This tool provides reverse shell over HTTP protocol, tunneled within HTTP protocol. It works in master-slave mode. You have the slave on the client and the master on the server, and you have reverse shell over HTTP protocol. Now, looking at these implementations, we find the following. First of all, some implementations, they don't provide you with interactive shell. Others do, but some don't. Now, all of them provide you with only one shell over the established TCP stream, which means the following. Once you have established the reverse shell tunnel, you can only have one shell process running on the client. You cannot open other shells at the same time, running at the same time over the same TCP stream. If you want to have multiple shells, you need to execute the command again and again, 3 times, 4 times, to have the number of shells you want. That's another weakness. All of them, they don't provide means of maintainability. For example, you establish the connection from the client to the server, and suddenly you want to change the server to a different IP address. You want to change the IP address. In this case, you have to rerun the program again on the client so that it connects to the new IP address. We cannot have a dynamic way of changing the server IP address on the fly. Now, if you are talking about advanced penetration test, we need a tool that provides us with dynamic way of changing the server address or port number on the fly. Another weakness we can see is every server can control one client at a time. You cannot control multiple clients at the same time. If you want to control multiple clients, you have to run the server multiple times at the same time, and every server is connected to one client. Again, in advanced penetration test, this is not very advanced. So, here comes the idea of next generation reverse shell, which provides maintainability, reliability, flexibility, which I'm going to discuss later on. Now, in order to see the need for these characteristics, let's review the modern network security architecture we found nowadays in modern networks. Mostly nowadays in most corporate networks, there are components, security components that are found in every networks, in even small corporate networks, they have these components. Whereas in the past, it wasn't like widely available. Every corporate network now, they have network level firewall, application level firewall, or protocol inspection scanning, IDS, IPS, DMZ, authentication proxy, and so on. These are very critical. And we are going to see why soon. Network level firewall, they just deny or allow traffic based on the source IP, port IP, source IP, destination port, and source port. Now, in the past, administrators used to place restrictions only on the inbound traffic, which is traffic coming from external, while outbound traffic, there was no restriction on that side. Now, nowadays, restrictions are placed on both directions. And this is very important because in the past, when you exploit a system, it was very easy to initiate, for example, a connection on high port number. Nowadays, you cannot do it. The protocol inspection engine monitors